6.5 Day 2. Today we're going to graph linear equations and linear inequalities. Now yesterday we did the same thing, but it's always important to practice the skills that you learn so that you feel more comfortable with them. So number 1, we're going to graph the equation y equals negative 3x plus 5. Why don't you hit pause, try to do this on your own, and see if you get it right. Hopefully, the first thing that you did was you discovered that the slope is negative 3. You'd also need to know that the y-intercept is 5. Knowing this information, we can first plot the y-intercept at 5 on our y-axis, and then use our slope of negative 3, which means down 3, right 1, to continue graphing our line. Once we plot at least 2 points, we can connect the points to make our line, and there we go, we've graphed the line. Number 2, again, hit pause, see if you can graph this equation on your own, and see if you get it correctly. Hopefully you discover that the slope is 1 over 2, and the y-intercept is 0, negative 4. You should have put a point on the y-axis at negative 4, and your slope is up 1, right 2. So you plot at least 2 points. I like to plot a couple more than that because it makes your line more accurate. So now we're going to draw a line to connect the points, and there you go. So hopefully you graphed your line correctly. Number 3, again, why don't you hit pause and see if you do this correctly on your own. When you're finished, come back and hit play to check. So first thing we have to do is divide everything by 2. When we do that, we get y equals 4x minus 5. Remember that an equation is not in slope-intercept form unless y is by itself. Once we have done that, m is 4, and our y-intercept is 0, negative 5. So we can go ahead and plot our y-intercept, and then our slope is up 4, right 1. And up another 4, right 1. And then we can connect our points to create our line. Now, yes, I know my line isn't perfect, but we don't expect it to be. That's why the more points you have, the more accurate your drawing will be, and your teacher will be able to see that you know what you're doing. All right, let's go ahead and continue. On the next page, we're going to continue looking at graphing linear inequalities. So let's go ahead. You can look at the steps to graph the linear inequality. You don't have to. Again, this is repetition from what we did yesterday. You always want to start by graphing your line, your boundary line. You're going to use a dotted line or a solid line. And then you're going to decide which area to shade. So let's look at number 1. It says graph the linear inequality. Y is less than 2x minus 1. Here, our slope is 2, and our y-intercept is 0, negative 1. So I'm going to go ahead, whoa, I almost forgot my parenthesis. I'm going to go ahead and plot that, 0, negative 1. And then I'm going to use my slope up 2, right 1 to put some more points on my graph. Now, once I am satisfied with the number of points I have, I can go the other way too. I'm going to go ahead and draw my line. Now, remember, because this is a less than symbol, we do a dashed or dotted line. So, dash or dotted. I'm going to go ahead and connect my points with a dashed or dotted line. So I'm going to make my pen a little bit thicker. There we go. And there is my line. Again, boundary line. Because it splits the graph into 2 regions. We have the region over here, and we have a region over here. So that is why we say that it splits it into 2 regions. Now let's see if I can undo that. Of course, I can't. So I'm just going to have to erase it, because these special tools that I'm using are covering my undo button. So we'll just erase that. I just wanted to point out to you how the line separates our coordinate plane into two halves. Alright, so now we have to figure out which side to shade. Let's go ahead and shade with red. Now we want values that are less than, and for less than you shade below the line, which would be over here, and if your line is a vertical line, then you would shade to the left. Now yesterday, a lot of people were having trouble deciding what side to shade. So one of the things you can do once you guess, so we're thinking it's the right side here or below the line, I'm going to pick a ordered pair. I'm going to go ahead in this case and pick -5, 0. So I'm going to call this my test point, and I'm going to plug it into the inequality. So my inequality is y is less than 2x minus 1. Now the point I picked is not in the shaded region, which means it is not a solution. So when I plug the point into this inequality, it should not be a true statement. So let's check. Now again, the test point was -5, 0, which means when I plug it in, I have a 0 is less than 2 times -5 minus 1. And if I simplify this, 2 times -5 is negative, whoa, not -5, -10. Let me fix that. All right, -10 minus 1, and 0 is less than -11. So notice 0 is not less than -11. This is a false statement. Since the point that we picked is not a solution, it should not be in the shaded region, which is correct. So we shaded the correct part. Now if you wanted to, you could check a ordered pair that's in the shaded region. So let me go ahead, just so we have some room, and erase the example we just did. And let's test another point. How about we test, let's test this point, 5, 0. So our new test point is 5, 0. And you can test any point you want. So our test point here being 5, 0, we're going to take our inequality, y is less than 2x minus 1, and we're going to plug in our value. 2 times 5 minus 1 is 0, less than 10 minus 1 is 0, less than 9. Yes, 0 is less than 9. Notice we picked an ordered pair that is in the shaded region. So it should be a solution, and it gave us a true statement. So that's one way you can check if you shaded the correct region. All right, let's go ahead and look at example number 2. First thing we want to do is identify the slope. Our slope is -1 over 2, and our y-intercept is 0, 4. First thing we do is plot our y-intercept. So there we go. And then we're going to use our slope, down 1, right 2, down 1, right 2, down 1, right 2. And again, I like to do as many points as possible because it makes the graph more accurate. So I can also go up 1, left 2, up 1, left 2, and then I can connect the points. Now, because it's an or equal to graph, we're going to do a solid line. So I can connect my points, and there we go. Now, it's a greater than symbol, so we're going to shade above our line, shade above. And that would be this area right here. If we shaded correctly, then I should be able to pick an ordered pair. Let's go ahead and check. Why don't we use this one right here? 0, 5. So we're going to test and make sure that is a solution. So the test point here was 0, 5. And the inequality is y is greater than or equal to -1 over 2x plus 4. And let's plug in. So y is 5, greater than or equal to -1/2 times 0 plus 4. Anything times 0 is 0. 0 plus 4 is 4. So is 5 greater than 4? It is. And if you notice, the point we picked is in the solution region, so it was important that it should create a true statement. All right, example number 3. Why don't you try this example, hit pause, see if you can do this one on your own, and when you finish, hit play to see if you did it correctly. Alright, there's the answer for number 3. You should have a slope of -1, a y-intercept of 0, -3, and you should have shaded below the line. Alright, let's look at the next page. Alright, we're going to graph the line x plus y is less than -1. Once we do that, we're going to check if the ordered pair 1, 4 is or is not a solution. So let's get started. First thing that we have to do is solve for y. So let's go ahead and do that. We're going to subtract x from both sides, and we get y is less than -x minus 1. So our slope is -1, and our y-intercept is -1. So we can go ahead and plot that. Whoops, not sure what happened. Did I go back to, went back to the first page. Alright, here we go. Alright, 0, -1. Not sure what's going on today. So 0, -1 is here, and then my slope is down 1 left, or down 1 right 1, down 1 right 1, down 1 right 1, and it's going to be a dashed line. Make the line a little bit thicker, so I'm going to make it my dotted or my dashed line. And now I need to determine how I'm going to shade it. It's a less than symbol, so I'm shading below my line, which is over here. So the question now is 1, 4 a solution? 1, 4. So that's where 1, 4 is. Now, based on the graph, it is not a solution. So we would say no. Now you can also check if it's a solution by plugging the ordered pair into the inequality. Now I'm going to go ahead and just use the original inequality. Let's go ahead and make this, I feel like a different color, but there aren't a lot of choices. We'll just do orange. Okay, so the original inequality was x plus y is less than -1. And our ordered pair is 1, -4, and I want to know if that's less than -1. 1 plus -4, oh wait, it's not -4. Oh my goodness, people, what am I doing today? Alright, let's erase. Let's try that again. Okay, x plus y is less than -1. X is 1, y is 4, and I want to know if that's less than -1. 1 plus 4 is 5. Now I want to know, is 5 less than -1? No. So notice our answers match. Based on our graph, it's not in the shaded region, and when we plugged it in, it's not a true statement. Alright, let's go ahead to number 5. 6x plus 3y is greater than 12. First thing we got to do is solve for y. So subtract 6x from both sides, and when we do that, we get 3y is greater than -6x plus 12. Divide everything by 3. And when we do that, we get y is greater than -2x plus 4. Our slope is -2, and our y-intercept is 0, 4. So let's go ahead and graph this. We have a y-intercept of 4, and we have a slope of -2. Now this is a greater than symbol, which means I'm going to do a dashed line. So I'm going to go ahead and do that. Dashed line. And then we need to decide where to shade. It's a greater than symbol, so we're going to shade above the line. Shade above. So above my line would be over here. Now the question in this problem is asking if 1, 2 is a solution. 1, 2. Notice that that falls on our line. And since our line is dashed, it means that any point that falls on the line is not a solution. So is 1, 2 a solution? We would say no, it is not. But again, we can always check it by plugging it into our inequality. So let's do that. The inequality was 6x plus 3y is greater than 12, and we're going to check 1, 2. So 6 times 1 plus 3 times 2 needs to be greater than 12 for this to be a solution. 6 plus 6 greater than 12. Is 12 greater than 12? No, it's not. So we answered correctly. All right, number 6. Why don't you hit pause, try this one on your own, and when you're finished, hit play to see if you did it correctly. All right, here you go. Here is the graph for number 6. The slope was -2, the y-intercept is 5. You should have a dashed line, and you should have shaded above your line. Now, is 1, 7 a solution? 1, 7 would be right here. Yes, that does fall in the shaded region, so we can say yes. Okay, there are 3 problems left, 7, 8, and 9. Graph each inequality and check if the given ordered pair is a solution. When you are finished, check them with an adult in the room. That's all, guys. Have a good day.